Imagine if an AI could not only see data, but also remember it, like predicting the next word in a sentence or the next note in a song. That's the power of recurrent neural networks, or RNNs. Today, we'll break them down step by step in the simplest way possible. So what exactly is an RNN? A recurrent neural network is a type of neural network that specializes in sequence data. Data that comes in order, like sentences, audio, or stock prices. Unlike traditional networks, RNNs have a memory that allows them to use past information for current predictions. Here's a simple analogy. Imagine you're reading a story. Each new word makes sense only because you remember the words before it. That's exactly how RNNs work. They keep track of context, just like our memory while reading. The structure of an RNN is simple but powerful. Each unit takes an input, processes it, and passes information not just forward, but also back into itself, creating a loop. This loop is what gives RNNs memory over time. To make RNNs easier to understand, we often unroll them. Imagine the loop unfolding over time. Now, you'll see the same RNN cell repeated step by step across a sequence, each one connected to the next by memory. Let's go through an example. Predicting the next word in a sentence. If the input is I love, the RNN remembers the words and predicts the next one might be pizza. That's how memory guides predictions. But RNNs aren't perfect. They face problems like vanishing and exploding gradients, which make it hard to remember very long sequences. It's like trying to recall the first word of a very long sentence. You tend to forget. To solve this, advanced versions of RNNs were created, LSTMs and GRUs. They have special gates that decide what to remember and what to forget, like a smart filter for memory. These models are much better at handling long sequences. RNNs are everywhere in real life, from powering Google Translate to speech recognition in Siri to predicting stock prices. RNNs are the go-to models whenever data comes in sequences. So while RNNs are powerful, they also have limitations. They're great for small to medium sequences, but can be slow to train and struggle with very long memory. That's why newer models like transformers are becoming popular. And that's recurrent neural networks explained simply. From remembering context like we do when reading, to powering translations and speech recognition, RNNs laid the foundation for modern AI. If you found this video helpful, don't forget to like, subscribe, and join me for more beginner-friendly AI explanations.